All right, so we're going to talk now about changes of state. And this is only one section in the book, but we're going to divide this out to at least three, I think, three lectures because I want to keep these in small bite-sized pieces, right? And this is a challenge. Changes of state is a challenge. So we're going to be talking about substances that go from solid, right, to gas or to liquid, right? From liquids to gases, from gases to liquids, right? These are changes of state. From gases to solid, and I guess the only one I haven't said yet was from liquid to solid, okay? So we're going to talk about that, and our learning goal then is to describe the changes of state among solid, liquids, and gases, and to calculate the energy released or absorbed. So the describing is going to be, I think, the easy part. Calculating is going to require some organization. I mean, it's not hard to calculate, but we just have to interpret things, and you have to have some sense of what's being asked, and sometimes that's what I would say is what gives students the most trouble, is calculating the energy. All right, so melting and freezing. First of all, melting and freezing are sort of the same thing, right? But one is backwards of the other. One is going from, melting is going from, I guess, a solid to a liquid, and freezing is going from a liquid to a solid. So a substance is melting when it changes from a solid to a liquid. It's freezing when it changes from a liquid to a solid, right? No big deal. And they're reversible processes, and we want to use those two terms interchangeably. Well, they're backwards of each other. We want to use those terms, I should say, comfortably, okay? Now, the energy that it takes to go from one to the other, the energy that it takes, we have to invest energy to melt, and we get energy out if we're going to freeze. That energy is called the heat of fusion. The heat of fusion. Okay, that's what the energy is called. That's how much energy it takes to freeze something, or to it's released if it's freezing, and if it's needed if it's melting. Okay, so the heat of and it turns out that it's defined as the amount that it takes to do 1 gram of that stuff, right? Which is kind of like what we did before, the specific heat, right? We did 1 gram, 1 degree centigrade for specific heat. Now we're going to do 1 gram to freeze or to melt, and that'll be called the heat of fusion, right? The heat of fusion released during freezing is exactly the same as the heat needed to melt the stuff, right? It's just the backwards of it, okay? So our core chemistry skill then is calculating the heat for change of state, right? So to melt water, watch this. To melt water, we have to invest 80 calories per gram, right? So here's a water solid, here's a water liquid, and that's how much we have to add to it in order to melt it, right? Now to freeze it, right, there's a liquid. In order to freeze it, we actually get 80 grams back out, right? And so here's some conversion factors. We've spent some time, we've invested some time this semester in making conversion factors, and you can see that there's 80 calories for every gram of water, or 1 gram of water for every 80 calories, right? Or 334 joules per every gram of water, or 1 gram for every 334 joules, right? So this, now, we can sort of make up our own formula for this. The heat is equal to the mass. Let me put it up here. The heat, which I'm using a Q for, is equal to the mass times the heat of fusion, which I'm going to say is like H sub F. That'll be our formula that we use for this, okay? Now let's do a learning check. I'm going to ask you to pause the video, and then come back, do a work on it, and then come back and check your work against mine. Okay, so I'm going to suppose that you did in fact cooperate and you paused it, right? Q is equal to M HF. How many joules are needed? And that's the heat right there, right? So let's do this here. To melt 32.0 grams. There's my mass. And the heat of fusion for water, remember, was 80, right? Remember that? Let's go back here. Let's go back to the previous slide. It was 80 calories per gram. But just a second here. We're being asked for joules here. Okay. So that was 334 joules per gram, right? All right, let me go back here. 334 joules per gram. And can you see I'm just going to cross my grams off and multiply? Right? There's my answer. There's my answer in joules. 32.0 times 334. 32 times 334 is equal to 10,688 equals 10,688 joules, right? That's Q. And so we might say it's 10.688 kilojoules. And this, watch this now, this was 3 sig figs. This was 3 sig figs. So I can only report this to 3 sig figs. So I'm going to say this will be reported as 10.7 kilojoules, right? Or 10,700 joules, depending on how that we want that to be reported. All right, so that's an introduction to heat of fusion, or to the changes of state. We just talked about one change of state, and that is melting freezing, and how to calculate with heat of fusion. Come back for the next video for more more states and more calculations.